All right, guys, here comes page 3. This first one is actually a decently difficult problem. Segment PS has a midpoint Q, so they've already given us the midpoint. What are the coordinates of P if S has coordinates of 1, -5? I highly recommend turning this into a visual problem. It can be done algebraically, it's just not as easy. So if we kind of look at this, Q is at 3, 5. And then I got S, which is at 1, -5. So if S is here and Q is here, Q is the midpoint. So I need you all to understand that point P is somewhere way up there. All right. But the cool part is if I just count, all right, if I run 2, if I go to the right 2 and then I go up 10, I get from one endpoint to the midpoint. So if I do that again and try and understand if Q is at 3, 5, if I go to the right 2, then my point is going to be at, instead of 3, it'll be at 5. 3 plus 2 is 5. If I got to go up 10 from here, if I'm at 5, I go up another 10, then I'm at 15. I did my answer pretty quickly. If I go visual, the algebraic move on that's a little bit more difficult. Okay? Here, if they say find WY, they are talking about distance between those 2 points or the length of the segment. There's a distance formula that I gave you, but I also told you it's a little bit easier if you count rise and run. 1, 2, 3, 4, 5. We have a rise of 6. And we ran to the left 8, but I don't want to look at it as a negative number because I want to look at this as a right triangle. If I have a right triangle, I can use the Pythagorean theorem since I know 2 out of the 3 sides. So 6 squared plus 8 squared equals C squared. 6 squared is 36, 8 squared is 64. And if I add those values up, I get 100. I don't want to know what C squared is, I want to know what C is. So the opposite operation is to square root both sides. And I find out that the measure of that segment is actually a really cool value of 10. Okay? Now, they want us to do the same thing, but with midpoint. All right? And just there's a couple ways to do this. One, we have a midpoint formula. Could go after that. That's not too tough. But also realize if we had to rise 6 and run 8 to get from one point to the other, the midpoint's going to be half of that movement. So if I rise 3 and run 4, every now and then I can do this maybe a little bit simpler. I just need to make sure I know where the coordinates of that point are. And the midpoint happens to be at -2, +5. If you didn't have a visual situation, you can always use the midpoint formula there. 17, they want us to find the distance between these two. Again, if we do it visually, we can use the Pythagorean theorem, but I'm going to go crazy and just show you an application of the distance formula. Distance formula again says x2 minus x1 squared plus y2 minus y1 squared. I just got to take those 4 numbers and plug them in. So I'm going to call this my first x and my first y. We'll call this one my second x, second y. It doesn't matter. You can actually switch those. Okay? But x2, 7, minus x1 is a -5. y2 is 13. y1 is 2. So it's a lot more possibility for small mistakes here, but you can stay resilient. You can get the answer just the same as we did with the Pythagorean theorem. If I'm subtracting a negative, those are going to cancel each other out. 7 plus 5 happens to be 12. 13 minus 2 is 11. I need to square those. Square root of 144 plus 121. Which means I need to find the square root of 265. So, if I pull up a calculator, I'm doing 265, and I need the square root. We're about equal, not exactly, about equal to 16.3. It did say round to the nearest tenth if I needed to. Okay. Last problem on this page. CD has these endpoints. Find the measure of CM where M is the midpoint. So I got a couple of steps to go through here. I need to find the midpoint first. Well, I've got the points, and I can just find the average of the x's. I can find the average of the y's. So I know that my midpoint, 3 plus 5 is 8, divided by 2 is 4. 9 plus 11 is 20, divided by 2. There's my midpoint. So I need that, and I need point C, which is at 3, 9. Okay. So again, I'm probably going to go distance formula since I'm not on a visual graph, so I can't make I could. But I'll go ahead and try the distance formula again real quick. I'm going to call C my second point, so x2 minus x1 squared plus y2 minus y1. Oop, no, it's supposed to be minus. Those are some of the common mistakes that can happen here. 3 minus 4 is a negative 1. Now here we got to be careful. Negative 1 squared is actually going to just be 1. 9 minus 10 is also negative 1. So if we square those, we're talking about 1 plus 1 square root of 2. If I wanted to plug it in a calculator, I could. Or you know what? I can actually just stop right here and have a beautiful, precise answer. So that is page 3.